So, what if I told you that the device you're listening to this on right now doesn't actually exist when you aren't looking at it?
It sounds totally ridiculous, right? Like magic.
Yeah, or like some late night dormitory thought experiment. But according to some of the most brilliant minds in physics and technology, it might actually be a terrifying feature of our reality. So, welcome to this deep dive.
Glad to be here.
Today, we are staring down a completely reality-shattering question. What if the stars, the air you breathe, and even your own memories are nothing more than lines of digital code running in an unimaginably massive supercomputer?
It's a premise that completely upends the absolute baseline assumption of, being alive, which
Mm.
is that reality is physical.
Right.
But this isn't just science fiction anymore. It's moved way out of the realm of cyberpunk movies and into serious academic laboratories.
Mm.
When you have leading scientists and prominent tech figures like Elon Musk, for instance, publicly stating that the statistical chances we are living in base reality are only 1 in billions, you really have to look at the underlying math.
Okay, let's unpack this. Because to hear a claim like 1 in billions thrown around by aerospace engineers and physicists, there has to be some heavy statistical logic behind it. They aren't just, guessing.
No, not at all.
So what is the actual math that leads them to that staggering conclusion?
Well, the math comes from a philosopher named Nick Bostrom. He proposed what's known as the simulation argument. It's often referred to as Bostrom's trilemma.
Trilemma meaning three options.
Exactly. He argued that one of three propositions must be true. So proposition one is that virtually all civilizations in the universe go extinct before reaching technological maturity.
Right?
Yeah, like they blow themselves up or climate change gets them long before they can build supercomputers capable of simulating reality.
That's the great filter theory, basically. We just destroy ourselves before we can build the matrix.
Correct. So proposition two is that civilizations do survive and they reach advanced technological maturity, but they completely lose interest in running simulations of their ancestors or other worlds.
Lose interest.
Yeah, maybe it's considered unethical or maybe it's just boring to them.
Okay, but considering how obsessed human beings currently are with virtual reality and video games and historical simulations, proposition 2 feels highly unlikely.
It does seem like a stretch.
Like, if we have the power to simulate universes, we are absolutely going to do it.
Right, which leaves us with proposition 3. If civilizations survive, and if they retain their interest in creating simulations, then they will eventually run millions, if not billions, of simulated universes using practically infinite computing power.
Wow.
And here's where the math traps you. If there's only one real physical universe, but billions of simulated universes running on hard drives inside that physical universe, what are the statistical odds that you happen to be in the one base reality?
Oh, I see. It's just a numbers game.
Exactly.
If there are a billion fake Earths and only one real Earth, the odds that my consciousness woke up on the real one are practically zero. I am mathematically guaranteed to be a digital avatar.
The sheer volume of simulated realities would just drown out the single base reality. Statistically, it is a near certainty that you are a simulation. But, the philosophy and the math only provide the motive.
Right, the theory.
If we want to find the actual proof, like the fingerprints of the programmer,
Yeah.
we have to look at physics.
And this is where we have to totally abandon our macro-level view of the world. Because if brilliant minds think our reality is fake, the clues aren't going to be found by looking up at the stars, right?
No, not at all.
The stars could just be a high-resolution skybox, like a painted ceiling in a video game. So to find the code, we have to look at the smallest possible pieces of the universe.
We have to zoom all the way in. You see, classical physics taught us to expect that matter is continuous. If you zoom in on a wooden table, you see fibers, then cells, then molecules, then atoms.
Yeah, the classic science class stuff.
Right. And the assumption was that you could theoretically keep zooming in forever, that the physical world was just smooth all the way down.
But the research shows that it's actually not smooth. When physicists look at the subatomic level, reality stops being continuous and starts acting in these incredibly strange, pixelated ways.
It really does.
It's as if there is a fundamental, hard-coded limit to how high the resolution of our physical world can get.
What's fascinating here is how closely this mirrors digital image processing.
Oh, interesting. How so?
Think of a high-definition photograph. From a distance, it is a smooth, continuous gradient of color. But if you zoom in tight enough, the illusion breaks. You hit the foundational building block of the image, which is the pixel.
Right? It gets all blocky.
Exactly. You cannot zoom into half a pixel. The pixel is the absolute floor of that digital reality.
And the universe has its own pixels. I was reading about the Planck length. This is a measurement so unfathomably small. It's something like a decimal point, followed by 34 zeros, and then a 1, in meters.
It is mind-bogglingly tiny.
And physicists say that below the Planck length, the laws of physics just completely break down. The concepts of distance and space literally cease to make sense. So, is the Planck length just the physical size of a universe pixel?
That is the prevailing theory among simulation advocates. The Planck length is the smallest unit of a three-dimensional grid. It implies that space isn't an infinite canvas. It is a rigid, quantified structure.
Like a cosmic checkerboard.
Precisely. And if the universe has a minimum resolution, well, that heavily implies hardware limitations.
Okay, let me test an analogy on you, because this reminds me so much of how a massive open-world video game works.
Go for it.
So, when you're playing a game, the computer's hardware is limited. It cannot process the entire digital world, like every leaf blowing in the wind or every NTC conversation miles away all at once. It would just crash.
Right, the RAM would overload.
So to save processing power, the game engine only renders the high-resolution graphics when your character looks directly at them. Everything behind you is essentially unrendered code.
It is an incredibly apt comparison, because in computer science, resource management is everything. Simulating an entire universe simultaneously down to the subatomic Planck level would require an amount of computational energy that basically defies comprehension.
Right, it's impossible.
An efficient program wouldn't render the dark side of a rock on a lifeless planet in the Andromeda galaxy. It would only render what a conscious user is currently observing.
But do we actually have scientific proof of the universe doing that, like rendering on demand?
We do. And it is arguably the most mind-bending discovery in the history of quantum mechanics. It's known as the double-slit experiment.
Oh, I've heard of this.
Yeah, so if you fire individual particles like electrons or photons at a barrier with two tiny slits in it, and you do not observe them as they pass through, they behave like a wave.
A wave.
Yes, they pass through both slits simultaneously, interfering with themselves and creating a wave pattern on the wall behind the barrier.
Wait. A single particle goes through both slits at the same time? That shouldn't be physically possible for a solid piece of matter.
It shouldn't be. Until it is measured, the particle does not possess a fixed physical location. It exists purely as a wave of probability.
That is wild.
It is essentially a mathematical equation where the particle might be. But the moment scientists place a detector at the slits to observe which one the particle actually goes through, the wave collapses.
It changes just because they looked at it.
Exactly. The particle instantly acts like a solid bullet and goes through only one slit.
So the particle literally doesn't take on a specific fixed position in reality until someone looks at it.
Observation forces the universe to decide. The mere act of measuring it changes the physical outcome.
My mind is completely blown because if we map that back to the video game analogy, it is identical.
It really is.
The universe is essentially saying, why bother spending the RAM to calculate the exact physical coordinates of this electron if nobody is looking at it?
Right. Why waste the energy?
It just leaves the electron in a blurry state of mathematical probability to save processing power on the cosmic server. But the moment a scientist points an electron microscope at it, the system panics and says, oh, a user's looking, render the particle.
You're describing the exact mechanism of a rendering engine. When we look closely enough with our particle accelerators, the memory-saving shortcuts of our reality are basically exposed. The code only executes the specific rendering when a conscious observer interacts with it.
Man, if the universe has a minimum resolution and it utilizes memory-saving tricks to render reality on demand, that creates a direct path of logic.
It does.
A system with hardware limitations implies a piece of hardware, and hardware implies an engineer.
A program necessitates a programmer.
Here's where it gets really interesting, because the physicists proposing this aren't talking about gods in the traditional spiritual sense, right?
No, not at all.
They aren't talking about a bearded figure in the clouds. According to this framework, the architects of our reality are just a highly advanced species, operating a few million years ahead of us on the technological timeline.
Yeah, given how far our own computing has advanced in just the last 50 years, from room-sized calculators to virtual reality headsets. Imagine what a civilization could build with 1 million years of iterative technological evolution.
It's almost unimaginable.
The simulations they could run would be utterly indistinguishable from base reality.
So who are they? I mean, who is running the server?
There are two primary hypotheses. The first is that we are an ancestral simulation created by our own human descendants from the distant future.
Future humans simulating past humans.
Yes. If humanity survives the great filter we discussed earlier, our computing power would eventually become practically infinite.
Okay.
Future historians might not study the 21st century by reading text. They might study it by running a high-fidelity simulation of the exact conditions of the 2020s and just watching it play out.
Oh, wow.
We wouldn't be living in the real 21st century. We would be digital constructs inside a museum exhibit generated millions of years in the future.
You know, I have to push back on this. This feels incredibly human-centric and, honestly, arrogant.
Fair point. How so?
Well, we like to think of ourselves as so fascinating that future super beings would dedicate massive server farms to watch us. But if future humans are running historical simulations, why simulate me eating a turkey sandwich on a boring Tuesday?
Right. Why bother?
Wouldn't they just simulate the major historical turning points? Why waste processing power on the mundane?
That is a very sharp critique, and it leads directly into the second hypothesis, which removes human ego entirely. We might not be the focus of the simulation at all. We could just be an emergent property of a broader experiment.
What do you mean by an emergent property?
Imagine an alien sociologist wants to study how planetary climates evolve. They boot up a massive simulation, inputting the basic laws of physics, a virtual sun, and a spinning rock.
Okay, tracking so far.
They hit fast forward to watch the weather patterns over 4 billion years. But because the simulation's physics engine is so incredibly detailed, single-celled organisms accidentally form in the virtual oceans.
Oh, I see where this is going.
Yeah, over a few simulated days, those organisms evolve, crawl onto land, invent the wheel, and eventually start recording deep dives about simulations.
Oh, wow. So we aren't even the point of the program. The alien programmer doesn't even know we're here. We're just like digital mold growing in the corner of a planetary climate model.
Precisely. We could be completely incidental. We are just highly complex algorithms that organically evolve within the boundary conditions of an alien simulation.
That is deeply chilling. It reframes all of human history. Every empire that has risen and fallen, every great work of art, every scientific discovery, it was all just incidental data points being generated by a weather program.
Yeah, it strips away our status as the protagonists of the cosmos.
If we connect this to the bigger picture, it really requires a complete paradigm shift, like a total ego death for the human race. We are not cosmic pioneers. We are subjects in a controlled environment.
Exactly.
Let's bring this down from the cosmos and into our daily lives, though. If we are running on a server, are there glitches that you or I might have actually personally felt?
That's the million-dollar question.
Like, have you ever experienced déjà vu? It's that eerie, sudden feeling that you have lived through a specific moment before.
Oh, absolutely. It is a nearly universal human phenomenon. Classical neurology usually brushes it off as a temporary misfire in the brain.
Right, like a sensory input mistakenly bypassing short-term memory and dropping directly into long-term memory, making the present moment feel like a recalled past.
Exactly, the biological explanation.
But under the simulation theory, déjà vu takes on a much more mechanical meaning. Instead of the classic sci-fi trope of a rewind button, I've heard it compared to a browser cache.
That is a much more accurate technical metaphor. Explain how you see it.
So when you load a website, your computer saves a local copy of it, a cache, so it loads faster next time. But if the server updates the website, your local cache gets temporarily out of sync with the live server pull.
Right.
What if déjà vu is just our localized digital consciousness lagging behind a macro server update?
Oh, that's a brilliant way to frame it.
The system is pushing a patch to the environment around us, our local memory cache stutters, and for a split second, we feel the jarring disconnect of data being overwritten.
That perfectly aligns with computational mechanics. It isn't a mystical premonition. It's the faint digital echo of a system restore point or an environment patch happening in real time.
But hold on, I'm spotting a glaring contradiction here.
Let's hear it.
Earlier, when we talked about the double slit experiment, he said, reality is probabilistic. Particles don't exist in a fixed state until we observe them. It's fluid. But if the universe is running on precompiled code, and patches are being pushed by an alien server, how can we have random quantum rendering A&D a predetermined script? If the system is just executing code, where is the randomness?
That is the ultimate paradox of the simulation argument, and it strikes at the very heart of free will. The contradiction resolves when you understand that the framework is predetermined, but the execution is probabilistic.
Okay, unpack that for me. I'm a little lost.
Think of an advanced artificial intelligence model today. like a large language model. The underlying neural network architecture is rigidly coded by humans. The training data is fixed.
Right, the parameters are set.
But the output the AI generates is probabilistic. It uses complex math to guess the next best word. The AI feels like it is choosing what to say, but it is actually just executing an incredibly complex mathematical algorithm based on its initial parameters.
So what does this all mean for our choices? Do I choose what I have for breakfast, or is that just the algorithm outputting the most mathematically likely scenario based on my previous digital inputs?
Well, if we are simulated entities, we are essentially highly advanced neural networks. Every thought you have, the person you choose to marry, the career you pursue, it feels entirely autonomous to you.
It certainly feels real.
But it is fundamentally the inevitable mathematical output of the initial conditions set by the programmer. True, unadulterated free will cannot exist if your consciousness is made of code.
That strips away all agency. We think we are agonizing over a difficult life choice, weighing the pros and cons, but really, our biological neural network is just crunching the variables exactly as it was programmed to do. We are just acting out the math.
And this framework dramatically shifts our existential fears. Historically, humanity has worried about spiritual consequences like divine judgment, heaven, or hell.
Yeah.
But in this model, there is no spiritual realm. There's only a physical server room located somewhere in a distant, unimaginable dimension, humming with power.
And the most terrifying part of that server room is that someone or something has access to the off switch.
That's the real nightmare.
Our entire reality, everything we have ever known, every memory we hold dear, is completely dependent on that hardware staying plugged in. A power outage in an alien laboratory, or a researcher deciding the experiment has run its course, and our universe just blinks out of existence mid-sentence.
The sudden deletion of the universe without warning or fanfare. It is an existentially daunting concept to realize how vulnerable the construct is.
I have to admit, standing here and talking through the physics of it, the Planck length, the rendering shortcuts, the statistics, it is profoundly terrifying. Knowing that our reality might just be fragile digital scaffolding makes everything feel incredibly hollow.
It does, but there is a philosophical reframing that offers a surprisingly robust comfort. We have to ask ourselves, does the nature of the reality change the value of the experience?
What do you mean?
Well, whether we are living in the original physical base reality, or whether we are highly advanced algorithms navigating a digital matrix, the experiences, the relationships, and the emotions are still completely real to us.
Right, they feel real.
The pain of a broken heart, or the profound joy of holding a child, feels mathematically and experientially identical, whether the neurons firing in your brain are biological tissue or simulated code.
So subjective reality is the only reality that matters.
Exactly. The authenticity of the human experience isn't dependent on the physical substrate it runs on. If a simulated tear feels like a real tear to a simulated consciousness, then the grief is real. The love is real.
That's a strangely beautiful way to think about it.
Even if it is a game, the feelings we have along the way belong to us. We still have to wake up and navigate our lives. The simulation is our base reality.
That is a powerful way to look at it. It grounds the existential dread quite a bit. But as we wrap up this deep dive, there is one final, chilling implication that builds off the ancestral simulation theory we discussed earlier. And I want to leave you, the listener, with this to mull over the next time you look up at the night sky.
Let's hear it.
So, if our future descendants are running this specific simulation as a historical experiment to observe their past, they are doing it to gather natural data on how early humans lived and thought.
Right, a sociological data gathering exercise.
Right. But we know from basic physics, the observer effect, that the moment a subject realizes it is being observed, its behavior changes. The data becomes corrupted.
The experiment loses its scientific validity.
Exactly. So if we are a historical experiment, wouldn't the exact moment we figure out we are in a simulation be the logical end of their useful data?
Oh, wow.
If we broadcast deep dives analyzing the simulation, the subjects are now aware of the lab. The experiment is officially compromised. And if the experiment is over, what is stopping the researcher from reaching for that off switch right now? The next time you step out of bed and expect the floor to be there, what if the simulation has finally decided it's time to stop rendering the floor? Keep that in mind next time you experience deja vu.